Please confirm me, all of you, my audio and video is clear or not. Right. Good afternoon, everyone. Welcome to 𝐁𝐚𝐴 English channel. My name is 𝐂𝐚𝐴, Faculty of Computer Science. Today I am discussing about theory of computation subject. So we are discussing here all PYQs, previous year GATE questions, which are very important for coming GATE 2025. So not only GATE questions, through questions we are trying to understand the concepts regarding question. Whenever we are solving question, the concept behind that question, that is also we are going to study here. So once again, I welcome you, all of you, to 𝐁𝐚𝐴 channel. Okay, right. Any doubts anywhere? If you feel anything confusing or any doubts you have, please ask me through chat. So I'm ready to explain from here. Okay, right. So our subject is revision through PYQs, theory of computation subject. So theory of computation is such a subject. If any audio video problem, please confirm me once, all of you. Theory of computation is such a subject. This is very important for GATE examination, and it is a high weightage subject and highly scoring subject also. Theory of computation, not only just a scoring, this is interlinked for compiler design. So if you are very confident about this subject, you can easily understand compiler design also. You can score good marks in the compiler design as well, because the concepts of compiler design also, most of the concepts are common concepts in theory of computation and compiler design. Okay, right. Good afternoon all, good afternoon. Welcome to 𝐁𝐚𝐴, all of you. Right. So first I'm going to discuss some of the questions here from our first, these are the topics I'm going to cover in this. Finite automata. Finite automata is the main concept. So first we'll discuss about finite automata as well as regular expressions. Both are same. Regular expressions, finite automata. Together I'll explain some regular expressions questions for that finite automata like this. So these topics are very, very important. We can expect easily one question or two questions from this in the coming GATE. So that's why we'll solve some of the questions related to regular expressions, finite automata initially, so which are asked in the previous GATE. How to solve those questions, and whenever we are solving these questions, what is the background concept behind those things. Okay, finite automata, regular expressions. Along with this, I'll once you are comfortable with this, we'll try to solve some of the questions related to regular language as well. This topic also very important for our GATE examination. Regular languages. So all these are interlinked concepts. This is after this we are going for context-free grammars. Inside that, push-down automata, non-deterministic push-down automata, CFLs. All these are the concepts we are going to discuss here. Then Turing machine, then undecidability. These are the topics, questions we are going to discuss in our today's session. Okay, right. So I think regular expression, finite automata, all these concepts are known for you. So here in this finite automata, our main focus is on DFA, NFA, epsilon NFA. Whenever we are discussing questions, so whenever we are solving questions of finite automata, these are the three. More machines are less important, very less number of questions you will get, but definitely will get good questions, and number of marks also more, high weightage for these three. Here conversion is one of the concept, as well as this DFA in this. Now initially let us try to solve some of the question related to this one. Okay, and along with this regular expressions questions also we'll try to solve here. So our first question here will be so what is the complement of, this is a question asked one time, the GATE paper. So this is one of the most interesting question and important question as well. One time I observed this in the gate. What is the complement of language accepted by NFA shown below? Assume sigma is epsilon is a empty string epsilon. Okay. What is the language? Normally what happens, complement concept normally not suitable. Complement concept is normally not suitable for NFAs. Directly we cannot complement NFA, but the question is very clearly there here. The complement of language, that is the way he is asking. So first I'll run a poll here. I'll run a poll and you first, we'll cover all questions chapter by chapter. First we are in this, after that we'll cover everything. First finite automata, then regular expressions like this. Undecidability also we'll cover in this, right? So I'm running a poll here for this. Give your answer in the poll. I'll explain afterwards, but these are the options here. And if you want, I can keep it this here only, right? What is the complement of language accepted by this one? Give answer in the poll. That is best approach. So epsilon NFA is given. He's asking for complement of language of this one. Right. Most of the students are giving answer here. Very good. See here, there are two methods of solving this question. One is directly analyze language from here, match this. That is one way. Otherwise, this is a epsilon NFA. Whenever epsilon NFA is given, first you convert an equivalent DFA for this. He is asking for complement. Directly, even if you complement here, you cannot do that. So if you make this as non-finals as finals, finals as non-final, such type of things will not work here. That will give you definitely wrong answer. That complement interchanging non-finals as finals, finals as non-finals, that complement concept whatever is there, that is best suitable only in case of your automata is the complement concept, interchanging of final and non-final states, that will work for DFA, complement of DFA. There you can, if DFA is given, you can interchange finals as non-finals, non-finals as finals. But here what is given? Here given automata is epsilon NFA. So conversion, perform conversion, construct DFA, you then complement, from there you identify the language. Complement DFA, from there we have to identify the language. So this is one approach. Otherwise, here you can identify, or you can construct a DFA here, the equivalent DFA, you perform conversion. I am directly writing here, the DFA will be like this. A, after this, any number of A's. For this automata, this is the equivalent DFA. For this epsilon NFA, You perform epsilon NFA to NFA conversion. If anybody required conversion, then also I can able to explain. Otherwise, construct DFA like this. Then you take complement of this. Complement of this. You interchange this non-final as final, final as non-final, like this. Convert this. Now it's language. Now what is the language accepted by this one? The language accepted by this one, this is accepting only epsilon here, only epsilon. So the answer for this is B. Only epsilon is accepted by this automata. Clear? So there are two approaches. You can directly analyze here. Otherwise, it is, what is the language? Try to identify language accepted by this automata. This automata is accepting 1A. Then you take this as a cycle. See here, this is looking like this. It is accepting 2A's, it is accepting 3A's, it is accepting 4A's, all number of A's except epsilon. Except epsilon. This is the language. What is its complement? Sigma star minus L. That means complement contains only epsilon. The complement of this, the language of this is like this, then its complement is only epsilon. So this is a normal way, manual way, and even if you want the conversion, through conversion also we can do. So through conversion, if you convert this epsilon NFA to NFA, NFA to DFA, we'll get this. Conversion not required like this, and you analyze and you can, for this question, it is not required. That conversion concept, it's a time taking concept, so better not to take here. Okay, right. I think I have explained the conversion concept in our yesterday's class, Maha revision. In Maha revision concept, there I have explained the conversion concept, how epsilon NFA to NFA will be converted, NFA to DFA is converted. You just go there and watch this conversion concept. From there you can easily clarify how to be converted here. Okay, right. Then minimal DFA, minimal state DFA. Which of the following is a minimal state DFA here? This is B, A, B. I hope these things are visible for you. A comma B. So this is the final state here, and it is the final state here. Right. So what is the language accepted by this automata? These two are final states here. These two are the final states. Shall I need to explain the conversion in the previous example? How many of you want conversion for the previous example? If you want, I'll explain. I can explain conversion, how this epsilon NFA is converted into NFA. So it's let me explain conversion once. Okay, it's very simple. This is epsilon NFA given. This is a small tricky one, epsilon NFA to NFA conversion, not much complex. It's easy one. First you construct NFA directly in table form. In table format. Take number of states are same. First you construct the same NFA, then we'll perform this NFA to DFA. That's the easy thing. Q0 on A. Here epsilons are there. Whenever you want to remove epsilon, with epsilon possible transition also we need to calculate, because we are removing epsilon in this. So with epsilon, whatever the transitions are possible, that thing. So Q0 on A. Q0 on A, what are the all possible transition? One is Q1. Next, see here, A epsilon is also A. A epsilon is also A. That's why A epsilon. So direct transitions, directly given with epsilon. With epsilon, whatever the possible transitions are there, those things also we need to include here. That's why with epsilon, it is reaching Q2. And then A epsilon, epsilon. Observe here, A epsilon, epsilon is also A. Epsilon, epsilon is also A. That means Q0 also. That's why Q0 on A, Q0, Q1, Q2. These are the reachable states here. Final states are from any state. By epsilon final is reachable. From here, epsilon final is nowhere reachable. That's why only Q1 is final. Final state is like this, only Q1. Is it clear? So Q0 on A directly, indirectly with epsilon, whatever the, with epsilon also A only. That's why with epsilon, whatever the transitions possible, those things also we need to include here. That's why, so A is Q1 we can reach, Q2 we can reach, Q0 with only Q0 on A. The similarly, Q1 on A, can you identify what are the reachable states? Q1 state on A, what are the reachable states? Q1 on A. So first epsilon A. So I'm writing here Q1 on A. So one possibility is epsilon A. That is also A. That means Q1, first self loop. Then epsilon A epsilon. So here I am writing here epsilon A epsilon. This is also A. So from starting from here, you reach here, reaching Q2 also, as well as epsilon. I am reading A only one time. So Q0 also, Q0, Q1, Q2. So Q1 on A, Q0, Q1, Q2. This is the concept. Using epsilon closure also you can do, but just it is like this. And similarly here, can you tell me what is the transition of Q2 on A? Q2 on A transition. Q2 on A. From Q2 on A. First Q1, epsilon A. Q1 is possible. Then epsilon A epsilon. Q2 is possible. Epsilon A epsilon epsilon. Q0 is also possible. So here also Q0, Q1, Q2. So every state, Q0 on A also 3 possibilities are there. Q1 on A also 3 possibilities are there. Q2 on A also 3 possibilities are there. This is our NFA. Now we have to construct an equivalent DFA from this. Any transitions? Do you have doubt in any transitions? Any doubt in any transitions of this? So the DFA, if you want to construct DFA, I have explained you already short trick. This is the actual method I am explaining. So look at this. The DFA start from Q0, Q0 on E, Q0, Q1, Q2, multiple transitions. So you can take as a state. I'm using next algorithm, NFA to DFA conversion algorithm. NFA to DFA conversion algorithm. Next, for every newly added state, we will provide transition. Q0, Q1, Q2. Q0 union of these three, same thing, Q0, Q1, Q2. So order is not a matter here. Q0, Q1, it's a set, order is not a matter. So like this. This is the DFA. Which one is the final state in this? Tell me. Which is the final state in this? Which state we can make it as final? Wherever final state is included, final state of epsilon and NFA is included, that becomes final. Wherever the final state of NFA included, that becomes the final here. So which one becomes final in this? Clearly it seems this is the final. So the DFA diagram, if you want to design, DFA will be, so Q0 and our final state is Q0, Q1, Q2. This is DFA. This is the DFA. Yes, this is the final state. This is the DFA. And we want complement of this. The complement of this, how it looks like? The complement of this is, this becomes final and this becomes non-final. So then what is the language accepted by this? Definitely epsilon. So like this. This is the whole method. So construction of NFA, then this NFA into DFA, and then this DFA into complement of DFA. This is the DFA complement. Whatever the DFA is, the DFA complement. This is what required for us. This is the whole method, but this is given for 1 mark, right? That's why this much of actual method. So that's what I am saying. If you want to get good rank in the gate, don't solve. This is actual method. This is actual method. But this method takes a lot of time. But in the exam, not advisable to do this method. Analyze the language. If it is for 2 marks, then somewhat a complicated question, that's okay. It is just for 1 mark. So analyze language from this. That is very easy. 1A, 2As, 3As, everything it is accepting. That's why. So directly analyze language and its complement version, whatever is there, that one you observe. So this type of questions we can easily expect. I have seen in some PSUs also, epsilon NFA is given. How many states are there in DFA? So if DFA states, there is a possibility of asking that type of question also from here. So if how many states are there in minimal DFA, what will be the answer? Tell me. If for the same question, how many states are there in minimal DFA? Minimal DFA states. This is also possible. This type of question also possible. Then what will be the answer here? How many states in minimal DFA? Minimal DFA of this. Two states. Okay. So such type of questions we can expect here. No. This is actually for the given question, that is not required just here. But if the question is minimal DFA, how many states minimal DFA? Then you need to perform a conversion. Then this previous conversion is required. Based on that, we need to solve. Right. Okay, that's all about this question. Let us try to solve this question. This is the given question here. I hope all these symbols are clearly visible for you. Self loops here, A comma B. Self loops here, A comma B. Final state. PQR ST. Right. How many states? Which of the following finite automata is valid minimal state DFA which accepts the language? These two, three states are there. In these two, we need to apply minimization in this. Okay. So let us let me start a poll for this. Give answer in the poll. Minimization. We need to perform minimization. There is a possibility of getting question from minimization. High possibility of getting questions from minimization. All of you, please practice more on some questions on minimization. That is required. Okay, very good. I hope minimization is very much perfect. Any inaccessible state in this? Any inaccessible state in this? Any state which is not reachable from initial? Is there any state like this? There is no inaccessible state. From the initial state, every state is accessible. So no need to delete any inaccessible states. Directly construct the table on AS, on BQ. Construct a table. It is easy for you to understand transitions. Then Q on A, T, on B, R, 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 S on A, S, R, T, T. So this is, oh, there are two final states here, S and T. These are final states. Apply our algorithm, state equivalence algorithm. All non-finals group separately. All finals group them separately. First step. So in the minimization algorithm, I am just solving this. So this state equivalence algorithm, whatever is there, minimization, this is best one. So easiest one also. There is no much difficulty. So all the non-finals group together, finals group together. What is the next concept? This is the only concept here. Some students will feel difficulty this, why I don't know. There is only simple thing. Take every two states, take their transitions, symbol A transition, falling under one group or different group. That you need to check. So PQ, are they equal or not? PQ on A, result ST, falling under one group. On B, QR, falling under one group. So no problem, still no, PQ okay, equal in this step. What about R here? Check with R and Q, Q and R and S. On A result, R and S. R and S there in different groups. S is there here, R is there here. Different groups means R is not equal with this. Split it. S and T on A, ST, falling under one group. B result, falling under one group. So S and T equal. So in S and T in this group, present group, previous group are same. No need to verify this. Just leave about that. Next one, PQ. PQ whether they are equal or not in the third step. That we will conclude from second. Now take the PQ A result ST falling under one group. But B result is QR. Observe here Q is there in this group, R is there in this group. So falling under different. That means PQ B result falling under different means PQ also not equal. P is separate, Q is also separated, R is also separated. S and T already two steps they are equal. Keep it as it is. So in this algorithm, what is the final conclusion we'll get? Equivalent states. Will anyhow this algorithm will do two things. It will remove inaccessible states, states which are not reachable initial. That is the one thing. Next one is equivalent states. What are the equivalent states are there? It will add. So as per this, can you tell me, this is this type of question asked in last year GATE also in 2024. So what are the equivalent states? Tell me. In this, which states are equivalent? This algorithm, actual main purpose of this algorithm is identifying equivalent states. Equivalent states, distinguishable states. Like this, two things are there. So this algorithm mainly observes on equivalent states. Very good. S and T are equal. So S and T becomes one state here. You can reconstruct a C here. P, Q, R. This S and T for this two states not required. Merge them into one state. S and T. That's why A is the answer here. Okay. So perfectly. So the actually 5 states are given. Minimal DFA of this contain 4 minimal states. Right. Any doubt in this question? Anybody having doubt in this question? Okay. There is one more question. So this is a question again asked one time. So which of the following are false? 4 statements are given. Which of the following are false? This is the automata. This is the finite automata which is given. Three states. Okay. So I'm going to run poll on this. These type of questions we can expect easily in the exam. Here regular expression concept is included, minimization concept is included. Okay, right. No one has given right answer. Okay, let us see. This type of questions, it's very important to solve. Whether it is given 2 marks or 1 mark, I don't know. This is actually given for 2 marks. Right. So let us see here. First one, true or false, tell me. The first one, whatever is given, whether it is true or false. Here this includes everything: regular expression concepts, DFA concepts, closure property concepts. All concepts are included in this. The name of the DFA is A. Language of this DFA, whatever is saying, is context free. First one, first statement is true or false. Is saying complement of L of A is context free, is saying. That statement is true or false? See here. What is this is a finite automata. Whenever finite automata is given, the language of this is definitely regular. Regular complement is what? What is the complement of regular? Regular complement is regular. Regular complement is regular. But as per Chomsky hierarchy, what is the Chomsky hierarchy? So according to the Chomsky hierarchy, this is a relation here. Every regular, this is regular and CFL relation. So can I say every regular is CFL? Every regular is context free? Yes. So he's not saying CFL but not regular. In CFL, two things are there: CFL context free and regular, context free but not regular. But he is saying context free means, so regular can be context free. That's why that case we have to consider. So it is context free, no doubt. Regulars can be called as context free. So this is true statement. Perfectly true. I'm writing this true here. It is true. Okay, right. So this type of questions worth for 2 marks. We can easily expect 2 marks, such type of thing, because every concept is covered in this. Good question. Can you tell me this 0 star, 1 star, this total thing? Can you simplify this? What is the simplification of this one? 0 plus 1 whole star, 0 star, 1 star. How can we write this? Can we write this as 0 plus 1 whole star? Is it equivalent to this? Is it true? Yes. So we can even 0 star, 1 star, even if it is this total thing is equal to 0 plus 1 star, because whatever we can generate from 0 star, 1 star, that we can get it from 0 plus 1 whole star. We can simplify this to this way. So this total language is, so L of A is nothing but now 1 star 0 plus 0 followed by 0 plus 1 whole star. So is it the language here? Even if you construct from this path is 0, this path is 1 star 0. So the language is 0 plus 1 star 0 followed by 0 plus 1 whole star. Second one is true. This is also true statement. Now, is it a minimal DFA? This one, is it a minimal DFA? Tell me. Is it minimal DFA? If you apply minimization, is it minimal? He's saying for the language accepted by A is the minimal. He's saying this is itself minimal. Is it minimal? If no, how many states in minimal DFA of this? Can you find out? How many states are there in minimal DFA of this? How many states are there in minimal DFA of this? So minimization concept also included in this. The minimal DFA of this, 2 states. So the minimal DFA will be like this. This is the minimal DFA. 1 star 0, 0 plus 1 full star. Okay. So you do the minimization, you'll get this. However, we did previously. So this is, he is saying this is minimal, this is false. All the strings of length at least 2. Is it length of the string at least 2? At least 1 also is accepting, right? How it is at least 2? Single 0 also accepting. So this is also false. This is also false. So what is the answer for this? 3 and 4. Right? False. Is it clear? Clear? Okay. Then let us see some more questions here. Minimal DFA, number of states of this is automata M, this is automata N. Consider the following: how many number of states in minimal DFA that accept this? So NAT question, I am running a poll for this, integer type, you answer in the poll. Someone asking 24. See 2024 questions, my questions recording is available. Please see there. Our PW series, my answers for the previous PYQs, 2024 PYQs available. Watch from there. Very good, very good, very good. So consider DFS M and N. This is a M here and this is N. Number of states in minimal DFA that accepts the language L of M intersection L of N. So can you identify what is the language accepted by this? Can you tell me what is the language accepted by this DFA? What is the language accepted by this DFA? First one, M, language accepted by M. Language accepted by M. Ending with A. This is ending with A. What is the language accepted by this one? Ending with B. See, gate questions are very logical. Gate questions, we don't find difficult questions mostly. That much complex questions we don't find. Logical, it will be there logically. Very good questions, they will frame. Right. So if I intersect these two languages, if I get intersection of these two languages, can you identify what is the language of this one? This is a set of all strings ending with A, set of all strings ending with A is this one, and all strings ending with B is this one. What is the intersection here? Is framing a language intersection. So can you tell me what is this language? L of M intersection, that means common strings. So can you tell me what is this language? What are the strings contained in this language? What type of strings contained in this language? L of M intersection L of N. L of M intersection L of N. Epsilon is not there here, epsilon is not there here, epsilon is not there here. How epsilon can be a common string? Epsilon is not the common string. Epsilon is not included in this, not included in this. How epsilon common string, intersection in the sense common string. So what generally will be the common string? This is nothing but clearly written, it's empty language. Otherwise, you just do the product automata on these two automata product. You know product automata, do minimization, that also okay. So the language is nothing but phi. Phi. So for phi, how many states in minimal DFA? Just two states, that's all. One state, just one state with two transitions, without final state. So answer for this question is one here, one state. It is phi. For phi we can construct finite automata, minimal one state. Clear? It's empty language. It's not epsilon. If it is epsilon, right? If it is epsilon, you have to construct your automata this way. For epsilon, this is the way you have to construct. DFA. This is the DFA for this. So if it is a epsilon you are saying, that is different, but it is not epsilon here. It is empty, phi. That's why our answer will be 1. Clear? Is it clear? It is empty language, it is not epsilon. Let us try to see some questions from regular expression finite automata. The number of states in minimal deterministic minimal deterministic finite automaton corresponding to the regular expression. This is a regular expression here. For this, how many states are there in this minimal? I think this is not the way of giving poll. Just a minute. New poll. Most of the students are giving good. Shall we need to construct or directly we can? If anybody interested, you can construct. Generalization also will be there. So DFA construction. Just we need to observe dead state required or not required. Three states here, three states. See, there are two ways. One way is directly we know the generalization. Set of all strings of A's and B's. Any string is ending with particular n length. N plus 1 states required. Set of all strings of A's and B's ending with particular n length. N plus 1 states. This is a ending with 2 length. So three states. Three states directly. Directly we can say three states. Otherwise, if you want to construct, we can do the construction also. One zero. Initially 0 comes like this. 1 comes like this. From here 1 like this. From here 0 like this. 3 states automata. No dead state in this. No dead state is required. If 1 0, then 1 0 final state, 1 0 final state. Any number of ones followed by 0 final state, 0 comes. Any zeros followed by, whenever 1 0 comes, automata reaches the final state. 3 states. Is it clear? No dead state is required here. In ending automata, we don't find any dead states. Clear? Same similar question, regular expression to finite automata. So sigma star, sigma star. Let L be the language represented by regular expression. Sigma star in the sense a plus 0 plus 1 whole star, 0 0 1 1 followed by 0 plus 1 whole star. This is what? Language represented by regular expression. Where this one? What is the minimum number of states in the DFA that recognizes this? So this complement concept is not required here. Minimum number of states that recognizes L. I'm running poll, so give your answer in the poll. What is the language here? Right. That's why better remember the generalization. This question, to solve this, we can easily solve in seconds. No need to construct here. Generalizations we have seen in the class. That is any set of all strings of A's and B's. Having this, what is the language generated by this one? What type of language? Try to identify language. N length substring. Set of all strings having n length substring. Set of all strings having n length substring requires n plus 1 states. N plus 1 states. N plus 1 states. Substring it is, substring. So n plus 1. So substring length is what? So here you can observe here also. Substring length, 4 length substring for 5 states. So number of states required here is 5 states. So answer here will be 5. Okay. So if you don't know this, again construction, time taking process. That's why our known generalizations, we made so many generalizations in DFA class. Please revise those things before going to your gate exam once. Okay. Let us solve some questions related to closure properties also. Right. Closure property. This is the question asked one time. L1 is A power n, L2 is B power n. L1 concatenation L2 is regular language. L1 concatenation L2 is non-regular. Which of the following is correct? So concatenation operation, or tell me concatenation is closed or not closed operation? Concatenation operation is closed or not closed based on that. Please give answers. Please give answers here. Don't unnecessarily write chat box. Very good, very good, very good. So there is a possibility of confusing. So just this question is given to in order to confuse you, that's all. This is regular. This language is regular. So it is A star. This is also regular. B star. Regular A star. So L1 concatenation L2. L1 concatenation L2 is A star B star. A star B star. Okay. But L1 concatenation, it is regular. He is saying it is regular. This is true. But in the second one, what he is saying, L1 concatenation L2 is saying that it is A power n, B power n. So, but in overview, it seems to be, it is A power n, it is B power n, A power n, seems to be okay. But here equality is there. The meaning of this is equality. So, from here I can take 3s. From here I can take 1b. That is allowed here. But this is, the meaning of this is first of all non-regular. This language is non-regular. But whenever you concatenate two regular languages, this is also regular, this is also regular. Whenever we are concatenating two regular languages, definitely we have to get regular, because concatenation operation is closed operation. But he is saying non-regular language, it is not. So he want to give actually A power n, B power m. This is the perfect way of giving. Just to confuse you, this is given. There is a possibility, but definitely it is not the language. This is the language. If I concatenate these two, we'll get this language. So in closure properties, confusion is a common thing. They will try to confuse you, but stick to your concept. The concatenation of two languages always close. So our answer will be definitely here A. Okay. Is it clear? Any doubts in this? Anybody having doubt in this? It is regular. It is, so A power n, B power n is not regular. But that is not, whenever you concatenate L1, L2, we will not get A power n, B power n. We will get A power n, B power m. That's why it is false. He is giving that L1 concatenation L2 is A power n B power n. That is wrong. It is A power n B power n. Okay, right. Let us try to solve one more question. This is also from closure properties. There are two statements. First one, if all states of NFA are accepting states, language accepted by that NFA is sigma star means complete language. Second statement, there exists a regular language capital A such that for all languages B, A intersection B is regular. Which of the following is correct? So give correct answer for this. Don't type in the chat box. Please don't type your answers in the chat box. But don't confuse remaining people also from the answers from the chat box, because some people are typing A, B, C. So those many cannot be correct, right? Give your answer, your own answer confidently. So answer here is B. So many of you are, I think, focusing on C. There is a possibility of confusing like this. That's why this question is given here. All right. Look at this. What is the first statement? If all states of NFA are accepting states, means final states, language accepted by that NFA is complete language. Is it true? So let me give, in order to give the counter example of this one, I am giving one automata here. This is one of the question which is this is DFA or NFA, tell me. If I give like this, DFA or NFA, this automata is DFA or NFA. We know the difference. That's why DFA detection we performed very well. This automata is a DFA or NFA. It is not DFA because missing transitions are there. From here B is missing, from here A is missing. There are so many missing transitions. That's why we cannot call this automata as DFA. DFA means, we know the definition very well. Every state, every symbol, transition should exist. For every state, every symbol, transition exists, then only we call it as DFA. But it is clearly not DFA. Now what is saying, if I make all states of, this is perfectly NFA. This is perfectly NFA. What he is saying is, if all states of NFA are accepting states, all states of NFA are final states, accepting states in the sense final states, then that automata accepts complete language. So let us make this one only. If I make this state, all states are final here, this is NFA. Is it accepting complete language? Tell me. Is it accepting complete language? Complete language means first of all it has to accept 2a. Is it accepting 2a? Is it accepting complete language? Is it sigma star? Is it accepting sigma star? No. Then how we can say all states of NF are accepting state, that language accepts a complete language. So the statement is clearly a false statement. False. Okay, here there are two statements. This is a very interesting point here. Assume I make a DFA. I am giving one more automata. Is it a DFA? Is it a second automata? Is it a DFA? So these are the points. These are the interesting observations from automata. So there is a possibility of getting question from here. This one is DFA. Second automata, second one, is it DFA? So from every state, from here AB transition, from here AB transition. This is DFA, right? Now, in any DFA, if I make all states as final, in any DFA, all states are final, that DFA accepts complete language. So this statement is suitable for DFA. In any DFA, if I make all states as final, the DFA accepts, because every transition is there. In DFA means every transition is there. If you make every state as final, everything it will accept. Now this is not accepting sigma star, but this is accepting sigma star, complete language. So these are the property. In DFA, all states are final. Whenever it is DFA, all states are final. In DFA, all states are final. DFA accepts complete language. But in NFA, that will not happen. Assume in here, in DFA, if all are non-final, what language it will accept? All are non-final. What language it will accept? All are non-final. This will accept empty language. So these are the observations here. So that's why he is saying NFA in this. It is not DFA. If it is DFA mentioned, this is the perfect one. That's why in NFA, all states are final states. It will accept complete language. The false one. Second one, see the second one here. So first statement is false. Second one, there exists a regular language, capital A. There exists some language, capital A, such that for all languages, B, there is some language. B is any language, any language. A intersection B is regular. So B is such type of, B can be any language, but A is such a language, A is such a language, A intersect with any language, we will get regular. Is there any language? Can you tell me any A exists like that? Can you give any answer for this? A intersection B, B you can take anything. A is such a language, B can be anything, but we will get regular. Can you give an example for A, for such type of thing? Is there any A like that? Yes. There exists a regular language A. A, if it is take it as epsilon. You have epsilon intersect with anything, with any B, we will get either epsilon or empty. So that is always regular. Yes, again you can take this as phi also, any finite language also. Okay. So this statement is true. There exists capital A. We have a language, intersection with any other will get regular. That is possible. That is possible. That's why second statement is true. First statement is false. So the answer for this question clearly only second is true here. So such type of questions possible from clear. Is it clear this question? Closure properties. We have one more interesting question here. This is a language. Regular expression to language. Number of states in deterministic finite automata accepting L. Okay. It's also very interesting. Minimal DFA is asking. Minimal DFA. It's given for 2 marks, but it's very easy. Okay. See here, I am writing some regular expressions. You tell me what is the language accepted by this regular expression. What is the language accepted by this regular expression? So immediately how to get that idea in mind. That's the main concept here. What is the language accepted by this regular expression? Yes, see here, from last position, whenever the string is ended from here, first, second, third, fourth symbol is A. Fourth position is A. First, whenever ended from this first, second, third, fourth position is A. Fourth, right? Fourth position from right hand side. Whenever the string is ended, from there if we count, fourth position is A while reading the string from right hand side. If the language is this, how many states in its minimal DFA? How many states in its minimal DFA? I think this is known thing for you. Whenever from right position, end position, nth input symbol, how many states in minimal DFA? How many states? This is a generalized one. We have generalized. This is 2 power n states. Here minimal DFA states are 2 power n. 2 power n states, 2 power n states, 16 states. Okay. In the same way, observe this. Observe this. This is also looking of the same. Whenever the string is ended, first position, second position. So second position is B. So this is A plus B whole star, B, A plus B. Whenever the string is ended, from this second position is, then how many states? So for this 16 states. For this 16 states. For the given thing, how many states? How many states? Tell me. For this regular expression, whatever is given in the question, how many states? Tell me. This is just for example I am giving. This is also similar, right? Whenever the string is ended, second from RHS is B, right hand side is B. So 2 power 2, 4 states, 4 states. Directly you can give answer, 4 states. So answer for this is 4 states here. Am I right? So this is same, just by if you observe this regular expression clearly, you can easily identify the language accepted by this automata. Any doubt in this question? So we have a question from grammars, regular grammar. This is a grammar, you can visualize like this also. Alphabet 01, null or empty string. This is a epsilon. Epsilon is an empty string. Set of strings x0, x1, x2 generated by corresponding non-terminals of a regular grammar. This is the regular grammar he has given. This is epsilon or lambda, it can be anything. Which of the following is the regular expression? String string. Okay, right. What is the regular expression for this? The question is, what is the regular expression for this? Type your answer in the chat box. So this is very rarely we'll get questions from regular grammars. This is one time we got question like this. Grammars, questions from regular grammars. So we have solved regular languages, regular grammars, regular expressions. Regular expression automata we are solving. But if it is regular grammar is given, this is the way. Okay, C is the answer here. Very good. Don't confuse. Grammar is given somewhat different way here, but equal or this arrow, it will be same. We can write this grammar is like this. X0 gives 1 x1, x1 gives 0 x1, or this plus indicates or 1 x2. x2 gives 0 x1 or epsilon. This is the way. We know the way of construction of, we know how to construct directly. This is right linear grammar. Right linear grammar, directly we can construct finite automata from this. How it is? X0, number of states equal to number of non-terminals. All the left hand side things are non-terminals here. So left hand side things are non-terminals. Whatever the starting symbol, can you tell me what is the starting symbol in this grammar? Which one will be the starting symbol? In any grammar, whatever is there in the first position, that is the starting symbol. So that becomes our initial state. Way of construction, automata, if we construct regular expression, grammar to regular expression, directly construction is a difficult concept. Turn them into automata. From automata, we can easily construct. That is the easy way. So here, on x0 on 1. So this is the way. On 1 going to x1. Corresponding to this production, give transition. This is the transition. And then x1 on 0, x1. x1 on 1, x2. This is okay. x2 on 0, x1. x2 on 0, x1. And wherever epsilon is there, you can make that as final. So our final state here is x2 is a final state. x2 is a final state here. Okay, right. So now we have to convert this into regular expression for this. So what is the regular expression? You just remove this cycle, remove this transition. You can add here 1 0 here. So this 1 0 cycle, whatever is there, you can add this. Just remove this transition. You can remove this. Now what is there? 1 followed by, what is the regular expression? 1 followed by 0 plus 1 0 whole star followed by 1 1. 1 followed by directly here 0 plus 1 0 whole star followed by 1. So answer for this is directly C here. C. So like this, whenever grammar is given, if it is regular grammar, first don't try to analyze. It takes lot of time. Unnecessary will fall into complex thing. So whenever regular grammars are given, first turn them into automata like this, convert in this way. This is the best approach. Okay. Clear? If you have any doubts in this anywhere, please ask me. Any doubt? Any doubt in this question anywhere? If there is no, some students are asking if no epsilon, then terminals will be there definitely. From the terminal, we'll take a final state. We'll take a new final state. From the terminal, we'll take final states. If epsilon not given, that is a different situation. But if grammar is regular, definitely finite automata will be constructed. Assume if terminal itself not there, grammar itself useless. Every non-terminal becomes useless symbol. There is no use with that. That's why definitely terminals will be there. Wherever terminal will be there from in any non-terminal production, from there we'll take the final state. That is the approach here. Okay. But language detections. Oh, language detection question is very common. So very common question in language detections. So especially in regular language. Sorry. Please try to analyze this. Which of the following language becomes regular? Three languages are given. Try to analyze which one is a regular here. Don't write your answers in the chat box. So answer is A here. Answer is A. Very few people. Okay. Right. Let us try to see this. Only where you will generally confuse here is, what about this one? A power P, A power P, B power Q, C power R. There is no dependency, any number of A's, any number of B's, any number of C's. This is clearly regular. Clearly regular. What about this? M is not equal to N. This is clearly non-regular. Non-regular. Okay. What about the first one? The first language is, this is actually regular. This is regular. I'll explain why. Wx W power R, W comma X belongs to A plus B whole star. This is like this. W X W power R, W comma X belongs to a plus b whole star, and w and x length is greater than 0 onwards, 0 onwards, greater than 0, that means start from 1. Whenever it says starts from 1, we can say w comma x belongs to a plus b whole plus positive closure. This is this language L1 here. This is our L1, right? So w x w power are this one, right? Now see what happens. You generate any string from this. W, take the w minimum value here. W minimum is, if it is a, it should be a in the middle, a plus b whole plus. X can be anything. It's b, w. Wherever dependency is there, that dependency due to with all just don't conclude based on this structure. Just don't conclude based on this structure. Generate strings. How the strings we are getting from this? So if it is b, a plus b whole plus, this is b. Okay. This is the, whenever I take w value as a like this, w value as b like this. Next, generate any string. Assume w is ab ab. W power r is ba ba. Reverse of this. X can be anything. See here, whatever the string you generate, it will be looking like starting with a, ending with a. Starting with a, ending with a, it is X. That means whatever the strings you are generating, all the strings of your language suitable with this regular expression, matching with this regular expression. Generate any other thing. You generate any string. W is ba ba. W power r is ab ab. As per the, see here, language means set of strings. As per this condition, if I generate strings, all the strings looks like matching with this regular expression. In the X, it can be anything. Now this again looks like this is B. This total, this is X. So this is, whatever the generated string will be covered by this regular expression or generated by this regular expression. That's why all the strings of this language equal to this regular expression. So language is our main thing. That's why this language is nothing but, we have a regular expression for this language, L1 a plus b whole plus a or b, a plus b whole plus. So this is so just based on the structure, don't decide. This is somewhat interesting language, very important one. So just the structure is not our language. The number of strings which are generated based on this condition or structure, that is our language. But the strings looking like starting with a, ending with a, starting with b, ending with b, this type of strings, for which we can easily construct regular expression. So if regular expression, if we are able to construct, language becomes regular here. So out of these three languages, L1 and L3 becomes regular. Language L1 and L3 are regular. That's why regular expression is possible. Clear? Is it clear? Any doubt in this question? So this type of questions also very important. So grammar to language questions are there. What is the language generated by given regular expression? This is a very easy one, but give answer for this. What is the language generated by this regular expression? This grammar, this grammar. So grammar to language questions also very important. Please observe those. Right. This is not, see here, set of strings generated by this is epsilon. It will generate A, B, AB, BA. This is complete language, A plus B whole star, not A power n, B power n. A power n, B power n means BA should not be possible, but B also possible here. That's why this is not your A power n, B power n. But anyhow, not this. So not this one, this is not regular, this two. So D is the answer, easy one. Like this grammars to given, then analyze from options. I hope with this we can close this regular part. We can move to context free. This is again from closure properties. There are two statements. Carefully solve questions carefully. Answer is A here. A. Right. Come to the second one, easy one. Class of regular language closed under infinite union. Regular language not closed under infinite union, closed under finite union. So this is false here. Second statement is false. Class of regular language closed under infinite union. So it is not closed. What about the first one? L1 union L2 is regular. So he is saying L1 union L2 is this result is regular. To say this total result is regular, both must be regular. Is it compulsory? If it is a union is closed, both are regular, okay. But both must be regular. To say a whole union is regular, is it compulsory that both should be regular? Let us take one simple example. This is a plus b whole star. This is a power n b power n union. Can you tell me what is the total union result? Complete language union with a power n b power n. What is the whole result here? What is the value of this whole union? A plus b whole star, right? Superclass union with, this is a superset, union with subset, a plus b whole star. So L1 union L2 is regular. L1 union L2 becomes regular. But where both the total result is regular. But why for that both must be regular, not compulsory here. Not compulsory. So what is the answer for this? So A is the answer here. Is it clear? In order to say both union of two L1 union L2 both are regular, L1 L2 must be regular is not compulsory. If any one thing is not regular, so that is sufficient here. Clear? Okay guys, then let us go for the CFLs, CFL detections, context-free language questions. Okay, consider the following language. Which of the following is not true? Give answer for this. In CFL, better go for detection onwards. Which of the following statement is not true? Not true. So in context-free languages, we start from detection onwards, CFL detections. Right. Look at this. What is the name of the language? Here also detection. First one, there is no dependency here. 0 power p, 1 power q. So this is regular. This is regular. Next one, 0 power p, 1 power q, p equal to q. Whenever there is a dependency, it is not regular. It's not regular, but it's CFL. By using push down automata, we can handle this. This is context free language. CFL, context free language. But what about the third one? This is also 0 power p, this is 0 power p, 1 power q, 0 power r. So whenever we have like this, so this one also, but p equal to q equal to r, all the three should be same. It is not CFL, not CFL. First, perform detection. There is a regular, CFL, non-CFL. The statements, push down automata can be used to recognize L1, L2. Yes, PDA can accept CFL, regular also. Push down automata, there is no problem with the push down automata. So we want not true. So this is true here. The first statement is true. Push down automata is used for detection of this. L1 is regular. This is also true. Detect. We perform detection. Turing machine can be used to recognize. Yes, Turing machine can able to recognize all these three. This is also true. Next, all the three languages are context free. No, now last one is not context free. So, but he is saying this. This is our false option, not true. So, answer for this is C here. C is the answer. Okay. So, detection of the language is the main thing here. So, from the second chapter push down automata, there mostly you focus on detection, CFL detection, closure properties. From there we can generally will get questions here. Okay. So here detection is there as well as closure property is there. So which of the following statement is false? Right. Answer is D here. This is first perform detection. A power P, 0 power P, 1 power Q, 0 power R. This is clearly regular. CFL, okay. This is regular. No dependency. This is regular. and P not equal to R, there is one dependency, no problem, we can handle with this PDE. So this is CFL, but not regular, not regular. So first we need to perform detection, then only it is easy for us to solve detection. Now which one of the following is false? So L2 is CFL, yes CFL, this is true. CFL intersection regular. What is CFL intersection regular result? What is the CFL intersection regular? Generally, whenever a context intersection with regular language operation, context free language intersection with regular. CFL intersection with regular definitely will get CFL. CFL. So CFL intersection regular, it is CFL. This is also true. Complement operation is not closed for CFL. Yes, complement operation is not closed for CFL. So CFL complement, no guarantee of CFL. What is CFL complement? It is recursive language. So this is also true. If it is non-CFL, then we may get recursive. Then complement of L1. What is L1? Regular. Regular complement should be regular. Regular complement. Regular language closed under complement. Regular complement is regular. But he's saying regular complement of L1 is context free, okay? Not regular is saying. Not regular is clearly wrong. This is false. False one. So this is the clear cut false option. Clear? So here it is, can take 0 power n, 1 power n, WC, W power R. W power R. W power R is the reverse of the W. Which of these languages are deterministic context free languages? Is asking for DCFLs, okay? DCFL detection. DCFL detection also very important. This is the question regarding DCFL detection. Is asking for DCFL. Right. C is the answer here. Which of the following is DCFL? What is DCFL? We have to construct the PDA, deterministic PDA. When DPDA fails, If there is no operation clarity, that means push pop operations, if you are unable to determine exactly what operation to be performed, now push exactly, pop exactly like this. But this is for this possible, this is DCFL. Here also, zeros push into the stack, for once zeros pop, logic clear. For W push into the stack, C skip, W power R, same symbol pop. Logic also works here, DCFL, this is also DCFL. But whereas WW power R, even length palindrome, for this DPDA not possible. NPDA possible, only NPDA. So this is DPDA not possible. So this is not a DCFL. Only here L1, L2 are our DCFLs. C is the answer here. Okay. If you have any doubts, please ask me out of a given thing. Which of the following are CFLs? CFL detection here. Easy it is, but seems bit confusing, that's all. There is a possibility of confusing, that's all. Nothing will be there. Okay, very good. B. So this is clearly CFL. We can write a power 2m plus 1. O can 2n plus 1. There is only one dependency. So this is clearly CFL. Right. Come to L1 and L2. L1 is CFL because see the logic, these two are same and these two are same. The logic is A is push into the stack, B is also push into the stack, A's pop B's, pop this, B's are coming, pop these things. So logic we can construct push down automata for this. This is CFL. But here in L2 this is non-CFL. Non-CFL because this A's, these two same and these two same. If we push A's into the stack, again if push B's into the stack, from bottom of the stack we have to pop. That is not possible. So this is non-CFL. Non-CFL. So our CFLs are clearly L1 and logic will not be suitable. PDA structure whatever is there, that PDA structure, whenever you are making logic to construct PDA, it is not suitable for our PDA structure for L2 language. So from bottom of the stack, A's we have to pop. For this A's we have to pop, which are there in the bottom of the stack. Stack violation. Okay, that's why L2 is non-CFL, L1 and L3 only CFL. Clear? Right. So here CFL and closure properties, there you focus. So those are the questions mainly required from this. Similar question. This is very famous question asked many times. So L1 is this one, L2 is this one. CFL detections and closure properties. These two are the major topics. There are very few questions from PDA. Which of the following are context free? Okay, very nice. So here this is CFL. These two are equal. A is push. This is CFL. This is also CFL. One dependency. So CFL union CFL. Union is closed. CFL. But intersection is not closed for CFL. Intersection is not closed. No guarantee. That's why intersection of these two languages, if you observe, A power n, B power n, C power m, intersection with A power m, B power n, C power n. Common strings. So the resultant language is nothing but A power n, B power n, C power n. If it is these two should be common. But here, whenever it is equal, these are equal here. So A power n, B power n, C, this is non-CFL, non-CFL. That's why which of the following is CFL? Only A here. Only A is the CFL. Okay. So like this, closure properties as well as CFL detection, these are the major areas where you have to focus from the second chapter. With this, I think we can move on to our RELs. It's better. Okay, decidable questions for which will come later. This is the question. Recursive languages. From recursive enumerables, better thing is closure properties. Focus there on closure property questions. There is a high possibility of getting question from closure properties. Closure properties, recursive enumerable languages as well as undecidability. Turing machine construction, there are less number of questions, very few times asked questions, but this closure properties as well as undecidability. These are the areas where you have to focus and solve questions more. Right. So try for this. What is the answer for this one? For this, definitely closure property table you should have idea. Idea of closure property table is required. I hope all of you remembered because we have very less time. If you have the idea of closure property table, then only we can solve this type of questions easily. Right. So B is the answer here. L1 is recursive language. L1 is recursive language. L2, L3 are recursive enumerable but not recursive. Okay. Right. Recursive enumerable language in which the table, closure property table is the main thing to solve these questions. Union is closed for both recursive and recursive enumerable. Intersection is closed for both recursive enumerable. But whereas complement is closed for recursive, not closed for recursive enumerable. That's why whenever any language, if you L2 if you take it, L2 complement. So there is no guarantee, so non-REL. L3 complement, non-REL. Okay. So because he is saying it is recursive enumerable but not recursive, so L2 complement, L3 complement are non-REL. So let us see these questions here. Union, intersection. In this, mainly these operations are major thing. Previously many times asked. Union, especially in recursive enumerables. Intersection, complement. Difference is just based on these three only. Complement. Difference, how we will write L1 minus L2, L1 intersection, L2 complement. This is the way we will write difference. L1 intersection and complement. That's why out of these three operations, if we have proper idea, we can easily solve. Most of the time questions also based on these only. Right. So let us see here. L2, L3. Two are RELs. Their intersection also REL. This is true. Which of the following is not necessarily true is saying. L2 RELs, their union closed. This is also REL. This is also true. Up to this, okay. Come to the A here. L2 minus L1, how we will write is L2 intersection L1 complement. This is REL intersection recursive complement. Recursive complement. What is the complement? Closed here. Complement closed for recursive. So this is REL intersection, we can say recursive. But if you observe the relation between recursive and recursive enumerable, every recursive is recursive enumerable. So this we can say REL intersection REL. Whenever it is REL intersection REL, that is REL. So recursive enumerable language. So finally this is also recursive enumerable. This is true. But in B what happens? L1 minus L3 complement. That means we can write it as L1 intersection L3 complement. What is L3 complement here? REL complement. Whenever it is REL complement, this is possibility of non-REL will get. But he is saying it is REL. That's why this is false here. So the answer for this is B. Not necessarily true is asking B. Like this, the closure property from closure properties, you have to remember the table is the main thing. If once you know the table properly, solving questions are very easy. There are so many questions in closure properties, but our questions are always same here. So this is one more question. Okay, it's also not required. This is a question. L1 is regular for all this. L1 is regular, L2 is context free, L3 is recursive, L4. All four languages are there. And we have closure properties of all the languages. If we have idea about all this closure property table, this type of questions we can easily solve. Okay. Give answer for this. All the four languages. Give answer in the poll, not in the chat box. Okay, right. Many of you are stuck in option B, right? Try to see here. So all four languages are given, then their closure properties. So to solve these type of questions, all the four language closure properties required, that is there in the table. So remembering the table is very important. First, L1 is regular, L2 is context free, L3 is recursive, L4 is recursive enumerable. Which of the following is true? First one, L3 complement. What is a complement? Recursive complement. Recursive complement is recursive. This is REL union. You can say this is REL union REL. You'll get REL. So this is true. No problem with the first one. And second one is L2 complement, union L3. See, context free complement not closed. CFLs not closed under complement. Not closed, what we'll get? CFL complement is recursive language. So recursive language. So this is recursive. So L2 complement is recursive. Here this one. Recursive union recursive. Recursive union recursive will get recursive. This is also true. This is also true. Third one, L1 is regular. Regular clean closure is regular. Regular almost all operations closed except subset and infinite union infinite. So CFL intersection regular. This is CFL intersection regular. CFL intersection regular. Definitely will get CFL. CFL. This is also true. This is also true. Fourth one, L2 complement. What is L2 complement? CFL complement. No guarantee of CFL. CFL complement is not closed. Not closed means no CFL. No guarantee. Maybe CFL, may not be. That's why whenever it is not CFL, it's union with regular, no guarantee of CFL. But he is saying CFL here. This is a false one. Fourth one is a false. Except this, first three are true. That's why D is the answer here. So like this, our closure property table, if we have, where which operation is closed, union, whether it is closed under recursive. If we don't know about these operations, it is difficult to solve. That's why the table is the most important thing. There are PYQs like this. So all of you careful about reading the table. If you have that table knowledge, it's very easy to solve this. Okay. Right. Now let us see decidable and undecidability questions. This type of questions generally will get from undecidability area. There are so many questions of this type. For this also, table, the table, undecidability table, whatever we have taken, so that table based on that. Okay. So but just by looking at the language, you should know about which operation it is, which problem it is. We have taken almost multiple problems, around 12 to 13 problems around we have taken in the table. So in that, membership, emptiness, finiteness, equivalence, completeness, which problem find out, observe with the table. That's why that table should be there in your mind. Then easily will get 2 marks. Right. Please find out what is the answer for this question. Which of the following undecidable? Just remember the table. That from the table we can solve these type of questions very easily. Very good, very good. Nice. So I think most of you are solving this type of questions very easily, because the table is the main thing. If you know that table properly, we can. What is the name of the first problem? The questions most of the time like this: which of the following problem decidable? Which of the following problems undecidable? Generally, we are getting these type of questions from this area, undecidability area. So this is the first one, emptiness problem of CFG. Emptiness problem. Emptiness problem. So this is called as emptiness problem. Emptiness problem. CFG in the table, if you observe, that is decidable. This is a completeness problem. Second one is completeness problem. Completeness problem is undecidable. Third one is regularity problem. This is called as regularity problem. So the regularity problem of Turing machines undecidable. This is the equivalence problem. This problem is equivalence problem. Equivalence problem of finite automata. Decidable. It is decidable here. The question is, which of the following is undecidable? Undecidable is asking clearly. So second problem is undecidable. Third problem is undecidable. So many questions are there in the previous papers. So of this type, similar type. So if you remember the table, knowing solving these problems becomes very much easy for you. Okay. So answer for this is D here. Any undecidability questions of same type? So no need to hurry about that. Okay. Okay guys, then that's all about. So started from DFA, finite automata, regular expressions, regular languages, language detection, clear properties, CFL detections, CFL clear properties, here clear properties of recursive enumerable languages. So almost all areas of theory of computation we solved PYQs here in today's session. Okay. So that's all about today's class. And today evening at 7 p.m. I'm going to take Mahabhyas in our GATE Wala Hindi channel. So we can join. There we are going to discuss about some of the very important questions, practice questions from theory of computation subject, topic wise, and expected questions in the coming gate. Okay. So I think today's PYQ's knowledge very much helpful for you for your exam. Okay. And all the best. All the best. Prepare well for GATE exam. Okay. Okay, guys. Let us see in Mahabia's class today at 7 p.m. And thank you. Thank you all. Once again, all the best for your exam. I hope all of you enjoyed this PYQ class. Thank you.